Uranus, the seventh planet from the Sun. A pale blue dot, barely visible to the naked eye. In the vast expanse of our solar system, it seems like a distant, mysterious world. And indeed it is. Imagine you are hurtling through space past the gas giants Jupiter and Saturn. You journey further into the cold, dark depths of the outer solar system. Then you see it. A giant blue-green world encircled by faint rings. This is Uranus, an ice giant with secrets waiting to be uncovered. Uranus is unlike any other planet we know. It spins on its side, its axis tilted at an almost 90-degree angle. Its atmosphere is frigid and whipped by supersonic winds, and its magnetic field is a puzzle, tilted at an extreme angle from its spin axis. Uranus was born billions of years ago, in the chaotic disk of gas and dust that surrounded our newborn sun. This swirling mass of material, known as the solar nebula, was the birthplace of all the planets in our solar system. Gravity pulled swirling particles together. They clumped and grew, forming the giant planet we see today. Over millions of years, these particles continued to collide and merge, gradually building up the mass of Uranus. Uranus, along with Neptune, represents a class of planets called ice giants. These planets are characterized by their icy compositions and unique atmospheres, which set them apart from other types of planets. They are distinct from gas giants like Jupiter and Saturn. This is because they have a higher proportion of heavier elements. While gas giants are mostly hydrogen and helium, ice giants contain more water, ammonia, and methane. But Uranus's birth was not peaceful. The early solar system was a turbulent place, with countless collisions and violent events shaping the planets. Astronomers believe that early in its life, Uranus experienced a cataclysmic event. This event was likely a massive collision with another celestial body. A planet-sized object may have collided with it. This impact would have been powerful enough to tilt Uranus on its side, giving it the unique axial tilt we observe today. This collision had a profound effect on the planet. It not only altered Uranus's tilt, but also influenced its internal structure and atmospheric dynamics. It is the most likely explanation for Uranus's extreme axial tilt. This tilt causes the planet to have extreme seasonal variations, with each pole getting around 42 years of continuous sunlight followed by 42 years of darkness. It also helps explain the planet's unusual magnetic field and the formation of its rings and moons. The impact likely caused a reorganization of Uranus's internal structure, leading to the complex magnetic field we observe today. Uranus is a world of extremes. Its seasons are unlike anything we experience on Earth. Each pole experiences 42 years of continuous sunlight, followed by 42 years of darkness. Can you imagine living in a place where day and night last for decades? The atmosphere of Uranus is made up mostly of hydrogen and helium, similar to Jupiter and Saturn, but it also contains methane, which gives the planet its distinctive blue-green color. This methane gas absorbs red light from the sun, reflecting blue and green light back into space. Deep within Uranus, beneath the layers of clouds, lies a vast icy mantle. This mantle is not made of ice as we know it, but of water, ammonia, and methane ices compressed to extreme pressures and temperatures. Uranus is a very cold planet. In fact, it holds the record for the coldest planetary atmosphere in our solar system. The temperature in its upper atmosphere can plummet to a frigid -224 degrees Celsius. This is even colder than the surface of Pluto. The winds on Uranus are some of the fastest in the solar system. They can reach speeds of up to 900 kilometers per hour. These winds whip around the planet at incredible speeds, creating giant storms that can last for years. Despite its frigid temperatures, Uranus is not a boring, static world. Observations have revealed dynamic weather patterns in its atmosphere. These include bright, rapidly evolving storms. Section 5. Uranus's magnetic quirks. Uranus has a very unusual and complex magnetic field. Unlike most planets, whose magnetic fields are aligned relatively closely with their spin axes, Uranus's magnetic field is tilted at a sharp angle. It is also offset from the planet's center, making it even more unique. Imagine a bar magnet inside Uranus, but tilted and off-centered. This is what makes Uranus's magnetic field so peculiar and fascinating. Scientists believe that this unusual magnetic field is caused by the planet's unique internal structure. It might also be influenced by the massive impact that tilted Uranus on its side. Uranus's magnetic field traps charged particles from the sun. This creates radiation belts around the planet, which are quite intense. These belts are hazardous to spacecraft and would pose a significant challenge for future human exploration. Section 6. Dancing Moons. Uranus has 27 known moons, each with its own unique characteristics and story. They are named after characters from the works of William Shakespeare and Alexander Pope, adding a touch of literary elegance to the celestial dance. These moons come in a variety of shapes and sizes, from tiny, irregularly shaped rocks to larger, more spherical bodies. Some are small and icy, reflecting the distant sunlight, while others are large and heavily cratered, bearing the scars of ancient impacts. Two of Uranus's most fascinating moons are Titania and Miranda, each with its own set of mysteries and wonders. Titania is Uranus's largest moon, and it's a world of icy cliffs and vast canyons, a landscape that hints at a dynamic past. Scientists believe that Titania may have once been geologically active, with internal processes shaping its surface. This means that it could have had volcanoes and even a subsurface ocean, making it a candidate for further exploration. Miranda is another intriguing moon, captivating scientists with its unusual features. It is the smallest and innermost of Uranus's 5 major moons, yet it holds some of the most dramatic landscapes. What makes Miranda so fascinating is its chaotic surface, a patchwork of different terrains. It is covered in canyons, cliffs, and strange, grooved features, as if sculpted by some cosmic artist. It looks as if it was shattered and then pieced back together, a celestial puzzle that continues to intrigue astronomers. Section 7. Could we live on Uranus's moons? The idea of living on a moon of Uranus might seem like something out of science fiction. But could it be possible one day? Uranus's moons, particularly the larger ones like Titania and Oberon, might hold some potential for human habitation. These moons have abundant water ice, a crucial resource for any future human outpost. The ice could be used for drinking water, oxygen production, and even rocket fuel. However, the challenges of establishing a human presence on these distant worlds would be immense. The extreme cold, lack of a substantial atmosphere, and distance from Earth would make it an incredibly challenging environment to live in. We would need to develop advanced technologies to overcome these obstacles. Section 8. Uranus's distant future. As our sun ages, it will eventually become a red giant star. This transformation will mark a significant change in the life cycle of our solar system, altering the dynamics and conditions of all the planets orbiting it. This will have a dramatic effect on the entire solar system, including Uranus and its moons. The gravitational forces and the intense heat from the expanding sun will create new challenges and phenomena for these distant worlds. As the sun expands, it will engulf the inner planets. Mercury, Venus, and possibly even Earth will be swallowed by the growing star, forever altering the inner solar system. It will also heat up the outer solar system. The increased solar radiation will reach the outer planets, including Uranus, causing significant changes in their atmospheres and surfaces. The increase in solar radiation could potentially melt the ices on Uranus's moons. This melting could lead to the formation of temporary atmospheres and even liquid water on their surfaces, creating a brief period of transformation. This would create temporary atmospheres and even liquid water on their surfaces. These changes could potentially support short-lived environments that might be capable of sustaining some form of life, albeit briefly. However, this phase would be short-lived. The temporary atmospheres and liquid water would eventually dissipate as the solar radiation decreases and the moons return to their frozen states. Eventually, the sun will shed its outer layers, leaving behind a white dwarf star. This remnant will be a faint shadow of its former self, emitting only a fraction of the light and heat it once did. Uranus and its moons will then enter a long, slow decline. The lack of significant heat and light from the white dwarf will cause these distant worlds to cool and darken over time. They will orbit the fading remnant of our sun, their once bright surfaces dimmed by the dying light. The once vibrant and dynamic system will become a cold and desolate place. But even in this distant future, these icy worlds will continue to hold secrets, waiting for us to uncover them. The mysteries of Uranus and its moons will remain, offering clues to the past and potential insights into the future of our solar system.